Welcome to qnawire.
So in this problem there are four parts that we have to solve, and first we'll be solving the A part. For that we'll be making the figure that is given in the question. So this is the figure given, and it is given that the change in internal energy of a gas when it is taken from A to C, this path, its change in internal energy, it is given as plus 800 joule, and the work done on the gas along the red path means this path, that means W ABC, it is given as minus 500 joule, and we have to calculate at how much energy must be added to the system by heat when it goes through this red path ABC. So for that we'll be applying the first law of thermodynamics, that is change in internal energy is equals to, and for path AC, let me write AC, change in internal energy for AC will be equals to the heat Q ABC, this path, plus W of ABC. So delta of AC we are given as 800 joule is equals to QABC plus WBC is given as minus 500 joule, so we can write minus 500 joule. From here QABC is equals to 1300 joule. So this is the answer for the A part. Next we'll be solving the B part of the question. So in the B part we have to find the work done in the process C to D. In this process we have to find the work done. Now work done C to D will be equals to, since we know that it's a constant pressure process, so it will be equals to minus PC times, it's P means, C means at this pressure is PC, times delta VCD, and here it is given one condition, that the pressure at point A is equals to 5 times the pressure at C. Now we know that change in volume in case of CD, this change in volume for CD will be equals to minus of change in volume in AB, and PA is equals to 5 times of PC, we know. So if you plug all these value here, so PC is PA by 5, so minus PA divided by 5, and change in volume for CD is equals to minus of change in volume of AB, so minus and minus sign will become plus, and we'll get change in volume AB in case of AB. Now if you find the expression for work done in case of AB, it will be equals to PA times, with negative sign, times change in volume in case of AB. So if we compare both these expression, we can say that the work done in CD, in case of CD, for the process CD will be equals to minus 1 divided by 5 work of AB. So this is the expression that we have got, and the work of AB is given as minus 500. So from here WCD will be equals to 500 divided by 5, because minus sign is there and minus sign is also there, so it will become plus, and it will be equals to 100 joule. So this is the answer for the B part. Next we'll be solving the C part. Now in the C part we have to tell that the energy exchange with the surrounding by heat as the gas goes from C to A by using this green path. So for that we'll be applying the first law of thermodynamics. So according to the first law of thermodynamics, the change in internal energy in case of CA is equals to Q CA plus W CA. Now if we calculate the work in case of this process, this plus this WCA will basically, the summation of this process, the work done of this process and this process. Since in this process change in volume is 0, so we can say that the work in case of CA is nothing but work which is equals to CD. So we can plug the value here, and CD we know, we have calculated, it is 100 joule, and QCA we have to calculate, and delta CA, delta AC we has given as 800 joules. So CA will be minus 800 joules. It just reverse the process. We have just reversed the process, so sign will become negative. So from here QCA will be equals to minus 900 joule, and where negative sign means that the energy must be removed from the system by heat. So this was the answer for the C part. Next we'll be solving the D part of the question. Now in the D part we have to find that the energy that must be added to the system by heat as the gas goes from C to point D. So we have to calculate QCD. For that we'll be applying the first law of thermodynamics, and from first law of thermodynamics we can say that QCD will be equals to change in internal energy for CD in the process CD minus WCD. And WCD we already know that WCD was equals to WCA, and WCA is 100 joule. So WCD we know it is 100 joule. Now we have to calculate change in internal energy for CD. Now change in internal energy in case of CD will be equals to change in internal energy in case of CDA minus change in internal energy in case of DA. Now in the problem, in the D part, it is given that the change in internal energy when the gas goes from D to A, it is given as 500 joule, and change in internal energy for CDA we already know that it is 800 joule. So but here we have to take a negative value because the question in the question it was given that the change in internal energy for ADC was 800. If you calculate for CDA, it will be minus 800. So minus 800 joule, and this is change in internal energy for DA, it is given that is 500 joule, but negative sign is there, so minus 500 joule. So after simplification we will get minus 1300 joule. So now we can plug all the values here. So this is minus 1300 joule minus WCD is 100. So we'll get minus 1400 joule. So this is the heat that we have to add to the system for the process QCD. So I hope you got the problem. Thank you.